Let's talk about dollar spot today and diagnosis of that disease. And want to show you the way that we incubate the samples. We've shown you this before. It's a white, or it's just a paper towel, 2 layers deep in the bottom. That's moistened, and then the samples are allowed to incubate in this shoebox. And there's a description of this shoebox from some of the irrigation audit work that we put up on the web for you also. But you incubate these samples. This has been incubated for 48 hours, and you can see we get quite a bit of growth of the fungus on the surface of the plants, right where there are some chlorotic symptoms showing. And I'll hold this up to the camera a little bit closer in a second with the hand lens, so you can see what it looks like in comparison to something like rapid blight, which can sometimes have similar surface symptoms, but if you incubate it, you won't see any mycelium develop at all on rapid blight. So that's a little bit different disease, easier to see. You'll never see that on rapid blight, this mycelium. But with dollar spot, in 24 to 48 hours, you'll get a good flush of growth if the disease is active. Now let's take a look at it with the hand lens. Okay, as you remember from previous videos, you use a hand lens. This happens to be a 20 power hand lens that will allow you to see some detail of the organism, but not too much. And then you have the sample that you want to look by holding the hand lens close to your eye and then moving the sample or the lens just a little bit to get a focus on what you're seeing in that sample. So that's sort of how you want to look at it to see what's going on. And you'll notice that it's sort of a clumpy look. So it's a lot of the mycelium tends to come off of the tips of plants. So it just sort of blows out the tops of plants when we see these in the lab. Now let's put the lens up to the camera like we would for our eye, and then we'll move the sample in and out to get a good look at the mycelium, and that's what you see. You'll see some mycelium there. There's no really other structures. It's similar to what you would see with brown patch or pythium, with the exception that the mycelium is clumped very frequently on the tips of the leaves, and you can see how it's not growing over the whole surface. There's little patches of hyphae, and that's very common with what we see. And the patch symptoms are not so tightly circular. Usually you'll see sort of an irregular pattern of patchiness from this disease. Let me look at the other sample here. Let's give you an idea. This is another sample and how it came out after incubation. But you see that blowing out of the tops of the tips of the leaves, you'll see some puffs of cottony puffs of mycelium on the top. So that doesn't give you a complete diagnosis of this particular disease, which is dollar spot caused by Sclerotinia homeocarpa. What we'll do is we'll take it to the dissecting scope and then to the compound scope and see the structures that give you a much better idea whether you're talking about the right fungus or not. But you really can't get this one down to a solid ID without using a compound microscope. Okay, let's take a look. Okay, here you can see the hyphae using a dissecting microscope, and what we're going to do is come in with a pair of forceps and collect a little of that hyphae like this, and we're going to pull it over and put it onto a microscope slide with a drop of water. Once we transfer the mycelium into the drop of water on the microscope slide, it takes just a minute to separate the mycelium out a little bit so that we get clean looks at just individual hyphae in that sample. So we need to just pull it apart a few times just to try to separate that big mass of mycelium into more spread out little strands of hyphae. Once we get this spread out just a little bit more, then we'll drop a cover slip on the top, and that'll provide the sample that we use for the compound microscope. And you see some air droplets there. We'll try to push that down just a little bit to push those air droplets out, so we get a little bit flatter sample for observation with the compound microscope. This is an image from the Pace Turf Gallery, and what it illustrates is the large primary hyphae on the bottom with the vacuoles or oil droplets in the hyphae, sort of circles inside the hyphae, and on the top it's the secondary very thin hyphae. The hyphae on the bottom range about 5 microns to 8 microns, and the thin hyphae are about 2 microns. So there's 2 different sizes of hyphae that should be present in the sample to pretty much confirm that it's Sclerotinia homeocarpa and attacking the turfgrass. Rhizoctonia, if you look back, has uniform hyphae and right angle branching, and Pythium doesn't have any septa. So we're going to be looking for septa, those oil droplets in the hyphae, and the two different size hyphae, secondary and primary hyphae. Well, we're pretty lucky with this sample because we can see clearly that there's the large primary hyphae that you can see up in the top there, and there's also other characters such as the septation or the septum can be seen in the sample. In addition, when we scan up the small hyphum up just above the word that says septum there, we'll be able to see that this is a secondary hyphae branching off. We hope you enjoyed this dollar spot diagnosis video. For more information about dollar spot management and control, refer to the links associated with this video.